Okay, today we are going to look at finding percent of a number. Here on page 104 in the 7th grade textbook, it says, to find the percent of a number such as 60% of 2,000, you can use either of the following methods. First, write the percent as a fraction and then multiply, or second, write the percent as a decimal, then multiply. Let's take a look at example number 1. It says, find 5% of 300 by writing the percent as a fraction. So when doing these problems, I don't need you to write the entire sentence in your notebook. What I need for you to do is to pick out the part that is being asked for. It says find 5% of 300. So I would put 1, 5% of 300 as the problem. And it says to turn the percent into a fraction. If you recall, when we talked about percents before, we said that the word percent means divide by 100. So if I think of that as 5 divide by 100, I can write 5% as 5 over 100. The word of in math oftentimes indicates multiplication. So that's exactly what we're going to do. We're going to take 5 over 100 and multiply it times 300. Well, we know that when we multiply fractions, we should take whole numbers and put them over 1. So what we get is 5 over 100 times 3 over 1. As we have done in the past, we can simplify things. 100 and 300 being diagonal from each other can be simplified by dividing both by 100. So the 100 becomes a 1 and the 300 becomes a 3. So what I end up with is 5 over 1 times 3 over 1, which is equal to 15 over 1, or just 15. So 5% of 300 is equal to 15. Take a look at example number 2. It says find 25% of 180 by writing the percent as a decimal. So again, I don't need you to write the whole problem out, but I would like you to write the 25% of 180. And it says to take that 25% and turn it into a decimal. In order to turn a percent into a decimal, all we need to do is remember that percent means to divide by 100. Well, whenever you divide by 100, the simplest way to do that is to take your decimal point and move it 2 places to the left. Never 1, never 3, always 2. So if I think of 25% as being 25 divided by 100, I can take the decimal point, which would be to the right of the 5, and I can move it 2 places to the left. And that would turn this into 0.25, or 25 hundredths. And again, the word of means to multiply, and then 180. Now, we're allowed to use our calculators in this chapter, so you could go ahead at this point and take 0.25 and multiply it times 180. And what you should find out is the answer is 45. So 25% of 180 equals 45. But remember, when changing a percent to a decimal, you need to move that decimal point 2 places to the left. Not 1, not 3, always 2. That leads us up to the first 4 letter problems on the bottom of page 104. Why don't you give those a try? Okay, on page 105, it says use percents greater than 100%. Percents that are greater than 100% can be written as improper fractions, mixed numbers, or decimals greater than 1. So 150% can be written as the fraction 150 over 100, which reduces to 3 over 2, which is also equal to the mixed number 1 1/2, or the decimal 1.5. In example number 3 here, it says, find 120% of 75 by writing the percent as a fraction. So again, we want to write the problem as 120% of 75. In this problem, they would like us to make 120% as a fraction. So again, the percent means to divide by 100, so we will put 120 over 100, and we're going to multiply that by 75 over 1. We need to do some reducing, and we can do quite a bit here. First, I notice that I have some zeros stacked up with 120 over 100. So I can simplify that by marking off 1 0 from each of those numbers. Next, I can see that 12 and 10 are both divisible by 2, so I can reduce the 12 to a 6 and the 10 to a 5. Now I'm going to look diagonally to see if I can do any reducing. And sure, 5 and 75 are both divisible by 5. So my 5 will mark off and become a 1, and my 75, when I divide that by 5, equals 15. So what I actually end up with is 6 times 15. So that's going to equal 90. So we can say that 120% of 75 equals 90. I would like to point out at this point that 90 is more than 75. When you take and multiply a percent times a number and the percent is greater than 100%, the answer you get will be greater than the number you started with. So our answer of 90 is bigger than 75 because our percent, 120%, is greater than 100%. Take a look at example 4. It says find 150% of 28 by writing the percent as a decimal. First, I'm going to write out my problem. 150% of 28. Remember, to turn a percent into a decimal, we need to move the decimal point 2 places to the left. Well, because I do not see the decimal point, I know that it is all the way on the right. And I need to move that 2 places. Remember, never 1, never 3, always 2. So the decimal is going to end up between the 1 and the 5. So I will actually end up with 1.5 or 1 5/10 times 28. Now, I am permitting you to use calculators to do these problems, so I can pull out my calculator and do 1.5 times 28. And what you should end up with is 42. So we can say 150% of 28 is equal to 42. And again, notice with the percent being greater than 100%, the answer that I got, 42, is bigger than the number I started with, 28. So whenever you multiply a percent of greater than 100 times a number, the answer you get will be bigger than the number you started with. That brings us up to letter problems E and F. Why don't you give those a try? Finally, we are on example number 5 on the top of page 106. It says, refer to the graph. If 275 students took the survey, how many can be expected to have 3 televisions each in their house? So, first of all, we got to ask, what are we trying to find? We are trying to find the number of students that can be expected to have 3 televisions each in their house. Since we are concerned with those students that have 3 televisions in their house, we should look in the graph where it says 3 in the survey. So we're only concerned with this part of that graph, which says 23% of the students surveyed have 3 televisions in their house. It says if 275 students took the survey. So it's 23% of 275 students total. So we can write our problem as 23% of 275. Now, it doesn't tell us which method to use here. So we have our own choice of doing so. Looking at the number 23, is this a number that can easily be turned into a fraction, reduced, and then multiplied by? Or would it be better off just turning that 23% into a decimal? Yeah, I think turning 23% into a decimal is the way to go in this problem. So again, seeing no decimal, I have to put my decimal point all the way on the right, and I'm going to move it 2 places to the left. Remember, always 2, never 1, never 3, always 2. So I get 0.23, or 23 hundredths, times 275. Now I'm going to pull out my handy dandy calculator, and I'm going to multiply 275 times 0.23, make sure I'm typing it correctly and I didn't put the decimal in the wrong place. And what I end up with is 63.25. I need to go back to my problem and make sure that that answers the question that's being asked. It says, refer to the graph. If 275 students took the survey, how many can be expected to have 3 televisions each in their houses? Well, 63.25 has a decimal in it, but we're talking about the number of students. So we need to consider whether or not this indicates 63 students or 64 students. Is this one where we have to round up or have to round down? I don't think we have to do either one. So what we should do then is to round it the way that the numbers tell us to. So since we would round to the nearest whole student, we would look at the first decimal place to the right. And since that is a 2, which is 4 or less, we would round this down to 63 students. So out of the 275 students surveyed, we could expect to see 63 students having 3 televisions in their house. That brings us up to the final letter problem here on page 106, letter G. Why don't you give that one a try?